Hello, this is Mrs. Myers, and today I'm going to teach you about medians and altitudes of triangles, which brings in area and perimeter a little bit. This is Unit 2, Lesson 6, and we're going to learn the properties of these two things, medians and altitudes. We've talked about the definitions of them before. I'm going to start here with a little recap from 2.5. I'm going to actually let you sort of take those notes and read them on your own. We did 2.5 angle bisectors and perpendicular bisectors before. The reason I have a recap here is because medians, altitudes, angle bisectors, and perpendicular bisectors do all have one thing in common, and that is that all of these, when you draw the three medians, altitudes, angle bisectors, or perpendicular bisectors in a triangle, they all come together at one point. So all four of these things are concurrent with each other. Medians are concurrent with each other, altitudes are concurrent with each other, etc. So these four things do kind of link together, but I'm going to skip down to our new vocabulary for this video. The first thing is a median. A median, by definition, is the segment drawn from the vertex of a triangle to the midpoint of the opposite side. So in this diagram, you can see we're at vertex A. The vertex or the vertices are the 3 points on the corners of the triangle, right? So we're at vertex A, and then we find the midpoint of the side across from A. So if this is angle A, remember the side opposite that is directly across. So to draw the median, you're going to start at the vertex and end at the midpoint of the opposite side. So that's the median. It says here that there are 3 medians that can be drawn. So I'd like you right now, on your own, to draw the other 2 medians. Clearly we're not constructing anything here. I don't want you to measure anything, but just eyeball the midpoint. So let's say if we're going to go from C and draw the median to side AB, first thing we need is the midpoint of that side. So I'm going to just kind of eyeball this and say, all right, that looks like about the midpoint. Now to draw the median, you just go from vertex to midpoint. That's it. All right, you draw the third one. It would go from vertex B and end at side AC. So find the midpoint of AC, vertex to midpoint. Now, to signify that these things are midpoints, you would want to label the diagram with those markings to show that these are medians, vertex to the midpoint. Okay. Remember, marking your diagrams is very important. It requires no words. If you put those markings on there to show that you've got 2 congruent segments here, then automatically we know that's the midpoint, and that's important. Okay, so just to tie this in a little bit with what we've learned about the coordinate plane, if we have a triangle that's drawn on the coordinate plane with the vertices 5, -8, -3, 12, and 4, 6, picture that. It doesn't have to be exact, but 5, -8, let's say, is down here. Y is -3, 12 is up here, and 4, 6 is here. So we have this triangle. Oh, there's a little curvy wave in my smartboard here. I can't draw a straight line. Okay. It says if the median is drawn from, this is X, this is Y, and this is Z. If the median is drawn from vertex X to intersect side YZ at point M, find the endpoints of the median XM. Well, we know that the endpoint of the median is at X, so that's going to be one endpoint. Well, we know those coordinates are at 5, -8, so that's one endpoint of the median. What we need is the midpoint of YZ, because that's where the other endpoint of our median is going to be, midpoint of YZ. Well, if you recall our midpoint formula, right, we add the x's and divide by 2, so we're finding the average of the x's, the average of the y's. So in this case, we're finding the midpoint of YZ. We're going to use these two coordinates, add the x's. That's -3 plus 4 over 2. And add the y's, 12 plus 6 over 2. Well, -3 plus 4 over 2 gives you a positive 1/2. And 12 plus 6 is 18 over 2 is 9. So the coordinates of point M are going to be 1/2, 9, which, you know, my picture is a little bit off, but that's where it would be. Okay, so that's just tying in the midpoint formula, which would be something you need with medians because a median goes from a vertex to the midpoint of the opposite side. Okay, so don't forget this point. The three medians of a triangle all intersect at one point, called a point of concurrency. In this, with medians, that point is called the centroid. It is the center of gravity of a triangle. That means that if you take the medians, well, actually, let's use this triangle we have up here, right? This point right here. So if, let's say this was a cardboard piece of this triangle was a piece of cardboard. You cut out that cardboard, you could balance your triangle right on this median, and it would be the perfect center of gravity. It would balance perfectly. So there's no circle involved with this one. You know, with angle bisectors, we had a circle that was inscribed, and perpendicular bisectors, we had a circle that was circumscribed around the circle. Medians don't have a significant circle to talk about, but that point of concurrency called the centroid is significant because it's the exact center of gravity. It's the center of the circle. I mean, sorry, of the triangle. Okay, if we look at the other side, we're talking about altitudes. Altitudes, you may have heard the word altitude in like an airplane. Altitude usually means how high you are, your elevation off the ground. Altitude in a triangle is a similar concept. If you think of this kind of as the ground, right? The altitude, if you're at the very top, this is like a mountain, the altitude is how high you are off the ground. It's not along one of the sides of the triangle, but it's actually straight down, perpendicular to the ground, or to the base, to the opposite side. So by definition, it's the segment drawn from the vertex to the opposite side so that it intersects at a right angle. In other words, it's perpendicular to the opposite side. Again, all three altitudes can be drawn, and when they are, they all intersect at one point of concurrency. This is an important little parenthesis here, right? The length of the altitude is considered the height of the triangle. So if this is the ground, how high is this triangle, or what is the height of this triangle? You would measure it from the ground straight to the tip of that. But remember that if you turn this triangle, then you have a different base and a different height. So if I trace this is A and B and C, if I, oh boy, now I'm really losing it. Trying to rotate this. There we go. If I rotate this, now I've got AC along the bottom. Here I had BC along the bottom. Now I've got AC along the bottom. Well, the altitude would be drawn from B straight down to AC. Well, in this case, then, the height is a different length than when BC was at the base. So it all depends on which way you turn your triangle, how you're going to measure the height. So that just means that there are 3 altitudes, all based on a vertex to the opposite side perpendicularly. All right, so here's an important point about altitudes. Sometimes the altitude is on the outside of the triangle. It is drawn to the extended opposite side. Okay, so if you look at the first triangle we have here, one altitude is drawn. If we draw the other 2 altitudes, you're going to go from B to AC perpendicularly. Now, careful, we're not going to a midpoint or anything. We have to actually make a right angle, which is sometimes hard to do. It's a little tricky. The third altitude goes from C straight down. Again, we have to make a right angle there. You don't want to make it acute or obtuse there. You want to make sure it's a right angle to the opposite side. So those are the 3 altitudes. When you have a triangle that looks like this, if this is the ground of this mountain, and you climb to the top of this mountain, if you're measuring how high you are off the ground, you're actually dropping an altitude outside of the triangle. It doesn't land right on the opposite side. It actually lands outside of the triangle. But that is how high you would be off the ground. So what kind of a triangle is this that makes you hang off kind of like a cliff? You're hanging over the edge here. That angle right there makes this an obtuse triangle. When it's an obtuse triangle, one of the altitudes is going to be outside of the triangle. The other 2, no problem. They're on the inside. Well, actually, I take that back. Not the other 2. One of them is on the inside, but the other one would have to be outside also. Like that. Right? So, notice we said the altitudes all meet at one point. You would have to extend these altitudes, and their intersection point would be way out here. Okay, so let's practice drawing some altitudes of triangles. You want to go from point B to side AC. Make sure it's perpendicular to AC. Sometimes you're going to have to extend the base. So I'm going to let you do that on your own. Pause the video and then try those on your own, and then come back and check your answers. Okay, so from point B to AC would be here. B to AC would be there. B to AC would be there. But here, B to AC, you would have to extend AC and make the altitude right out here. Okay, the last concept here relates altitude to its most significant usage, and that is when we're finding the area of a triangle. So the formula for area of a triangle is 1/2 base times height, sometimes written BH over 2, B times H, and then divide by 2, where the base and the height are always perpendicular to each other. So that is the significant thing. The base and the height are perpendicular to each other in this formula. So you're basically talking about the altitude and the base that it's drawn to, the side that it's drawn to. That's what you're multiplying to get the area of a triangle. So obviously there's 3 combinations for getting area. You could use this side as the base and its altitude. multiply them together, divide by 2. Or you could use this side and this altitude and multiply those together and divide by 2. So the important thing is you have to use the base and the altitude that goes with it. So when you're looking at a basic problem like number 2 here, okay, we've got all of these different dimensions. This side is 16, this side is 12, this side is 30, and this measurement is 8. Well, when you're finding altitude, look for that right angle symbol. That's what tells you that that's the altitude. And in area formula, we need the base and the height that are perpendicular to each other. So if I'm going to use 8 as my altitude, when I'm finding area, I need base times height divided by 2. The height is actually the length of the altitude. So I'm talking about multiplying by 8, right? That's my altitude. I need the base that's perpendicular to it. So when you look at this diagram, which side is perpendicular to the 8? That would be the 30. So when I'm finding area of number 2 here, I would do 30 times 8 and then divide by 2. And that's going to give you 240 divided by 2, which is 120. Remember, area is square units, so square centimeters. Don't forget that perimeter, let's just do perimeter for fun here. Perimeter would be adding up all of the sides, the distance around the outside. So if you started at this point and you walked that length and then the next length and then the next length to get all the way around, you don't include the altitude obviously in that one. It would just be 30 plus 12 plus 16, which equals 58. And in that case, it's plain old centimeters, not square, because you're just talking about distance. Okay, this is important here too, but I'm going to let you think about that one on your own. And we will practice this more in class. Thank you very much.